All right, this is the 2013 AB question number 1. So on a certain workday, the rate in tons per hour at which unprocessed gravel arrives to a gravel processing plant is modeled by this. So notice that is the rate, where T is measured in hours between 0 and 8. At the beginning of the workday, which time equals 0, there are 500 tons already at the plant. During the hours of operation between 0 and 8, the plant processing gravel at a constant rate of 100 tons per hour. A, find G prime of 5 using correct units. Interpret your answer in the context of the problem. So you're going to take the function G of T and you're going to take the derivative of it. Okay, this is a calculator problem, so you might as well just go ahead and use your calculator. G prime of 5 is equal to negative 24.588. So what does it mean? It means the rate at which the gravel is arriving is decreasing by 24.588 per hour at time equals 5. So the rate at which the gravel is arriving is decreasing by 24.588 tons per hour at time equals 5. Part B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So if we want to just talk about the amount that arrived, we're going to integrate the rate that it came in from 0 to 8. You're going to integrate from 0 to 8 of G of T dt, and again, completely put this in your calculator, and you're going to get 825.551 tons. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time equals 5? Show the work that leads to your answer. Okay, so first thing we're going to do is we're going to find out how much unprocessed gravel, what the rate is at time equals 5. So let's start there. So at time equals 5, it'd be G of 5. We know it's arriving unprocessed at 95.140764 tons. But what we also know is that it's being processed at 100 tons per hour. Now, since this is less than 100 tons per hour, we know that the amount of gravel that is unprocessed at that point is decreasing because we can process more than we're actually bringing in there. So at time equals time equals 5, the rate of unprocessed gravel is decreasing since it's less than the rate, since the rate dropped off is less than the rate processed. D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation? Okay, so again, the amount that we want to find the maximum, so we know the amount given at any given time is the amount there was at the very beginning, which is 500. And then you're going to integrate from 0 to t of the rate that it's being dropped off minus 100, because that's how it's being processed per hour. So we want that to be a maximum. If you want to maximize something, you have to take its derivative, set it equal to 0, and find its critical point. So doing that, we have A prime is going to be g of t minus 100, and we're looking when that's equal to 0, and that happens at time equals 4.92348. All right, you can find that by either putting this in your graphing calculator and looking for the x-intercepts, or you can look at the graphing calculator where g of t and 100 intersect. But we have to check the endpoints because this is a closed interval. So we need to look at the time and then the amount. We know at time 0, there was 500. At time 4.923, there's going to be 635.376. And then at time 8, there is 525.551. At time equals 4.923, the amount of gravel is at a maximum of unprocessed gravel is a maximum. And I'm going to go back and make sure they didn't ask me for how much it was. It just says, what is the maximum amount? With the max being 635.376 tons. So at the end, always make sure you go back and see, did you actually answer the question? Okay, so how was the scored on the AP test? 1 point for finding G of prime of 5, 1 point for the justification. Part B, 1 for the integral, 1 for the answer. Part C, 1 that you're comparing G of 5 to 100, 1 for the answer. D, that you're considering A prime of t is the first point. The next point is the answer and the justification.